Well, my name is Kelly Riley. I'm with Methods Workshop International, and I'm here to do a presentation on predetermined time systems. So the presentation is going to consist of some history of how the industrial engineering came into being, also about the evolution of predetermined time system and time studies in general, and then finally the application of predetermined time systems. So as you may have already figured out based on what I'm going to talk about, we do sell predetermined time systems. So having said that, let's get this presentation started. So those of you who have an industrial engineering background, this will be a little bit like a flashback of like going back into IE 101. Okay, Frederick Taylor was known as the father of industrial engineering. In the mid-1800s, he actually started coming up with the idea of how to start measuring work. And when he first started this, he was actually working in the field of construction. And while he was observing all these people, he started noticing that the workers, there were some workers that had great big shovels and others that had little bitty shovels, and people were working at different rates. He started thinking, I wonder how I can maximize this. So he was watching the guys with the great big shovels, and they were moving more dirt at a time, but he also noticed they had to take more breaks. About every 10 minutes, they got fatigued and had to take a break. The guys were moving with the little shovels actually could work longer, but they weren't moving as much dirt at a time. So he started experimenting with different shovel types, and he finally realized that there was a particular size that they could use where they could move more dirt and not get fatigued. And he actually found a significant improvement in the amount of digging and dirt that they were able to move. So that's where the idea of measuring labor first came into being. Okay. Taylor developed the concept of scientific management, which evolved into analyzing work tasks and optimizing them for maximum efficiency. Again, he started that with just the idea of digging holes and digging dirt. He developed time and motion studies to identify unnecessary motion and reduce wasteful actions, resulting in higher productivity. And Taylor also introduced incentive systems and to motivate workers to increase productivity, including piece rate systems and bonus systems. After Taylor, about around the same time, they actually overlapped some, but Frank and Lilly and Gilbert were the next one to really add it into the industrial engineering field. They were known for their work in time study and motion analysis and the workplace efficiency. And then the interesting thing about this is that Lillian was actually a psychiatrist, and she was more interested in the conditions of the worker and the well-being of the worker. So it was a combination of where not only are we trying to maximize the output of a worker, but also how can we improve the work conditions and make the worker more satisfied. Okay, so they were strong advocates for the human side of industrial engineering, recognizing the importance of worker well-being and job satisfaction. They were also the first one to started looking at a motion economy, and that was actually, everybody's heard of ergonomics, which is where you have all the chairs and things and trying to make sure you don't have a repetitive motion problem. So they were the first one to really started working on trying to make that and reduce those type problems. One of the famous quotes that came from Frank and Lilly and Gilbert was, "There is no waste in the world that equals the waste of needless, ill-directed, and ineffective motions." This person, almost everybody in the world knows who he is. He's Henry Ford. So the next one that built on top of the Gilberts was Ford himself. He's the one that finally broke the pass down to where you had an assembly line. And he became extremely famous and wealthy, making cars, of course, by breaking the job down into smaller segments so people could become more efficient at their jobs. And he also came up with the idea of interchangeable parts, making it to where the car, he didn't have to keep as big of an inventory. So the concept that he laid down became groundwork for the scientific management that we use today in modern manufacturing. Okay, the power of industrial engineering principles to improve the manufacturing efficiency and productivity, and the concept again of the interchangeable parts. My favorite quote from Mr. Ford is, whether you think you can or whether you think you can't, either way, you're right. So I've always thought that was pretty neat. So now getting into a little bit more of the details about what time studies, a predetermined time system. So a predetermined time system is a method used to set time standards for specific tasks in a manufacturing environment. The goal is to identify and eliminate unnecessary movements, improve worker efficiency, and reduce production costs. Some history on this is motion time analysis is the foundation of the predetermined time system, which involves breaking down a task into specific motions, measuring the time it takes to complete each motion, and then this information is used to develop a standard or a SAM, the amount of time required to complete a specific task. So a little bit of history. The predetermined time system was originally developed back in the 1940s by Cortell and Kittenberg. And of course, this was just a further continuation of the work done by Taylor and the people I mentioned earlier. So the original system was MTM1, and MTM1 is the most precise MTM system that you can actually have. The problem with it is that the motions are so small that it takes a long time to do an analysis. It was actually broken down into movements such as reach, and then another movement would be grasp, another movement would be to move it, to position it, and with each one of these, and release it at the end, and with each one of these movements, not only did you have to identify the movement, but you also had to measure the distance of the movement and give it a classification of difficulty of A, B, or C. So although it's a very specific, very precise way of measuring somebody's setting a standard, it is very cumbersome for using as an actual system for setting production standards. So then the next system that came along was MTM2. They're trying to reduce the number of codes and make it easier to apply, make it more practical to use in a manufacturing environment. And what they did was they combined these codes together to make only 2 codes out of about 5 or 6 codes, which became known as your gets and your puts. MTM2 is a very precise system to use for setting production standards. So some of the benefits of using a predetermined time system that's for manufacturing companies is it increases efficiency, improves worker productivity, and reduces production costs. It eliminates human errors such as missed pace rating workers, favoritism towards certain workers, and changes in mood and time-studied analysis, and can create an imbalance, create an imbalance within an incentive system. And eliminating the pace rating is one of the most important parts of using a MTM, a predetermined time system. I have gone into many factories, and I can do an exercise where I deal out 30 cards, and in a certain amount of time, in 30 seconds, it's considered 100%. I've got a team of engineers sitting in front of me now. I'll ask them to pace rate me as I put these cards in the stacks. And almost without exception, I will find anywhere from a 20 to 30% difference between what one engineer believes the pace I'm working at doing another one. When you have these types of inequalities on your floor, it actually kills the incentive system and creates actually tension on your production floor. So by using our system, you can eliminate that, just making sure that all your production rates are set in a very fair and balanced manner. Okay. I've already actually gone over that information. Okay, after MTM2 was created, they actually went ahead and moved it to the next level, which was MTM core data. And core data was a culmination of all of these prior systems put together, culminating in one value at the top, which was just an average of all the values that of all the prior systems. So basically, MTM core data is a MTM predetermined time system with one value at the top and MTM1 as its base. So you can use any system in between that, depending on what your requirement is, in order to set a production standard. So, and our system that we sell, ETC, is based in MTM core data. Motivating workers. So anytime that, in order to use it, you don't have to have an incentive system in order to use our system, because you still want some way of measuring your output against an international standard. But normally our system is used in conjunction with an incentive system. So an incentive system, if you're actually paying somebody on day work or hourly, then if you move from that to an incentive system, you normally will realize about a 20 to 30% increase in your productivity. So, and if you think about it, it's the fairest way to pay somebody. What you're really doing is taking your hourly employees and turning them into an individual contractor. So this way that they are actually being paid by the number of pieces they do, and they're more involved and more motivated to get the more pieces out at a good quality so that they can earn more money. So some of the keys to having a successful incentive system is, first of all, you must have fair and accurate and consistent standards. Again, the system we sell, provided that the people are properly trained, will help eliminate any differences in making fair and accurate and consistent standards. Allowances that are required for delays that are common in the workplace must be put in. And whenever you're working, there will be what you call on-standard and off-standard conditions. And if off-standard, if something be outside of the operator's control happens on the floor, then that time must be documented and in order to protect that worker's pay. And this actually works in addition to protecting the worker's pay. It also makes it where you can create reports that show you where your lost time is. So if you have lost time, you will get a report that says, hey, you have this many much time lost for machine delays. The machines were broke down. The work wasn't brought out there right. You had a bunch of needle breaks, and so it breaks it down into all the different categories where you might be losing productivity. It makes it where you can actually identify where you're losing the most time, and you can focus your resources on fixing that problem. Okay. Benefits to predetermined time system over using a stopwatch. It eliminates pace rating, as I already mentioned, which is one of the biggest problems you can have when you use multiple engineers to set production rates. It forces the analyst to pay attention to the details, which almost always leads to an improvement in your methods. And the time values that we use are accepted as international standards of what 100% pace is. The method, once you're done with the analysis, your methods you have a very descriptive, highly descriptive report that shows you exactly how the method is done. We usually use a video documentation also, which is great for training purposes as you grow and bring new people in. And it's just a preferred manner for setting time standards. So next, I actually have a video of a little picture of Elon Musk, and that's only because I think he's really cool, and I really like Elon, so I just wanted to throw that in there because go Elon. All right, so if you're not using don't have SAMs on your floor, know what a SAM is, standard allowed minutes, we want you. It's time for you to come on board and start moving from hourly into a incentive system and using standard allowed minutes to not only to do all the things that you can do that industrial engineers use this for. Some of the things that we use it for would be things such as determining how much work to load into the plant, determine when the dates of delivery dates for training purposes, determining how many units per hour can be made, determining how many machines are required in order to get whatever product line set up, and to how much work to put in for the operator. Okay, this is in Spanish, this part. Also, it helps you control your efficiency. Not only does the system give you, our system does not do this, but the system shop floor control system will give you not only operator efficiency, but also plant efficiency. Okay, it helps for you to determine your cost, not only for cost for running the plant and determining what your actual production costs are, but it also helps you cost products for future work that's coming in. And it also helps for methods improvement. Again, you got to focus on details when you're doing these analysis, which helps you make a more efficient method. Okay? So Sam, with the stopwatch, I've already kind of taught this. First, you got to time the operator. You're going to break it down. Then you've got to pace rate the operator. After that, you got to add your time. Now, the time complementarity is actually time that you can add in order to make the operator run more than 100%. But and some companies choose not to do this, but a lot of companies, if you want to use a high task or low task system, you'll put in a additional time to bring that time value down. And then also you have your time for personal fatigue and delay, which is your supplementary times, and all these are required in order to arrive at a proper SAM. Okay, let's go. Here we go. And again, if you're not using current SAMs, we invite you to come by our booth because you need to be moving from an hourly to a standard implementation, a standard set your SAM. We got to get you on the SAM. So how can you do this? Engineered True Cost will do it for you. The predetermined time system is specifically designed for the sewing industry. Garment doesn't matter if it's needles going in it. We can set a standard with our system. It gives you descriptive methods and standards of exact time. Here's an example of what an analysis looks like, where you actually have your codes down one side, a description of the motion, and then once you've got all the codes in, you wind up with your SAMs, a cost in dollars, and it also gives you the operator output that would be 100%. Okay, so ETC gives you a method. It arrives at a time. It will tell you what your production costs are, and it will help you do capacity planning. So we also have another system that is called QTC. And with this system, it does not give you operations does not give you your time values on an operation level. It'll give you an overall SAM for any product. So if all you're needing at the time is to know how many minutes are actually in a shirt, but you don't need to know it at the operation level, this system will give you that time within a plus or minus 4% accuracy. So so let's just say you have a brand retailer, what do they want? They want it cheaper, they want it quicker, they want it better. So here's an example of what our system does and how it works. If you look over here on the side of here, if you look on the page here, you'll see on the left-hand side you got sew, seam, parts, match, corners, bar tack, buttonhole. So you don't have to be an engineer in order to use this system. If you can count and you can measure, then you can use this system. Now you do have to know some basic knowledge of methods because there are a couple of fields that have to be filled in that require some knowledge of actually the construction process. But the first one, sew, is all you got to do is measure the number of sewing inches. The next one, seams, that's just the number of times that, like your shoulder seam, your side seam, you just count the number of sewing seams there are. You enter that into the system. The next is parts. So you just count up the number of parts. Your collar might have 3 or 4 parts in it. Your band's got a couple of parts. Literally, all you got to do is take your patterns, lay them out, count all your parts in the pattern, plus any labels and buttons. All those are counted parts. You count them up, and you put that factor into the system. Then next, you have match points. This is where you do need to have a little bit of knowledge with the actual construction of a garment. A match point would be considered something such as if I'm sewing a side seam closed and I have to stop and make an alignment in the middle of the seam. That's a match point. Okay, so you would have to, so there is some requirement to fill this field in of knowing the actual sewing process of garment construction. Okay, the next one is corners. So a corner is anywhere that a person would put a needle down and pivot around a corner. Again, this one does require some knowledge of the construction process. Next, you have bar tacks. Simply count the number of bar tacks. Anybody can do that. Buttons, count the number of buttons, count the number of buttonholes. I'm sorry, that one was back tack, not bar tack. But back tacks, and then you got bar tack at the end. And then if you have any snaps or drippers, you put that in. Once you enter that information, it will come up and tell you the total minutes you can see on the screen. So your total minutes is like 12.94, and the labor cost based on whatever your hourly rate or your base rates are, it'll give you that cost. So, and the next numbers you see down below, if you put in like an efficiency of the plant, so you know your plant does not run at 100%, no plant does, and you know what your plant efficiency is, you plug that in, so that will add in your inefficiencies, just bringing the time value up and the cost. So that's just a way of taking what was 100% cost and basing it on exactly what your plant history of productivity is. Okay. Absolutely. Oh, you want me to back it up? Sure.
This is the checkbox area located
Hey, I want to get this. Okay. Good? All right. Yeah, you're very welcome. All right, so again, quick crew calls. I want to make sure everybody understands that ETC is an engineering tool. Quick crew cost is more of just an upfront costing system that you do not, it's not really a tool used for engineers to try to improve your efficiencies on the floor. Okay, so one's a tool for engineering to help improve efficiencies, one to give you a quick and accurate cost of a product that you may or may not get into production later on. Okay, so again, Uncle Sam wants you. We want you to come on board with us, start doing your costing the scientific way, accurate and precise. So I invite you to come by our booth, 1709, right around the corner here, to visit. Again, I'm Kelly Riley, and I'm with Methods Workshop. Thank you very much.